Okay, this is section 1.7. In this section, we're dealing with inequalities. The first part of this section, we're going to be dealing with polynomial inequalities. And in the second part of this section, we'll deal with rational inequalities. And those are the goals of this section, to be able to solve polynomial inequalities and rational inequalities. All right, some preliminaries going into all of this. Definitely be able to just be comfortable with interval notation. Here I just put you a few little reminders of interval notation. Here's the inequality, x is bigger than a, that's how you say that. This is the interval notation equivalent here. So parentheses a to positive infinity, and as a sketch on a number line it looks like this. It's all the values a, not including a, that are bigger than a, so to the right of a. X is less than a, that just means, well, x is less than a, that's the inequality. This is the interval notation, and this is what the picture looks like. You could have what's called a compound inequality. It's two inequalities in one. The way you read this is that x is less than b and bigger than a, and the interval notation for that is parentheses a comma b parentheses. It's all the values that are between a and b, but not including a and not including b. Remember that there's also brackets. So if we are dealing with this type of thing, bigger than or equal, less than or equal, those require brackets. Yeah, so just be aware of interval notation. We're gonna be needing it. Another thing that you definitely want to be aware of right now is that you need to change the direction of the inequality symbol whenever you're multiplying or dividing by a negative number. So the direction of the inequality symbol changes if you multiply or divide by a negative number. Keep that in mind. Okay, let's get into some polynomial inequalities then. Let's first just kind of think of a guideline, some guidelines on how to solve them. So an inequality, a polynomial inequality looks something like this. Here I have a polynomial of degree n. It's a polynomial of degree n. It's less than 0. That's a polynomial inequality. I could change this less than to bigger than, less than or equal, or bigger than or equal. It doesn't matter. How do you solve this polynomial inequality? And note that right now my polynomial inequality is in a sense set equal to 0. There's a 0 on one side of the inequality, and there is the polynomial on the other side. You don't have to do that. It just makes the process a little bit more defined. It's easier to come up with a procedure when you set things equal to 0. Otherwise, each inequality would be different. So how do you solve this type of an inequality? Step 1. What you gotta do is just first solve the polynomial equation. So literally just erase whatever inequality sign you're dealing with and change it to an equal sign and solve. That might be a complicated procedure depending on the degree of your polynomial. For a degree 2 polynomial, a quadratic, there's a quadratic formula. But for degree 3 and higher, the situation gets a little bit crazier, harder. So first of all, step 1, solve the corresponding polynomial equation. Step 2, plot the solutions found in step 1 on a number line. Then what this does is it splits the number line into intervals. And then step 3, you use a test value from each interval to determine which intervals form the solution set. And that would be a rough guideline on how to solve a polynomial inequality. We'll use this once we get into some examples. All right, so let's get into some examples. Well, let's think about some examples here. The first example I want to deal with is this inequality right here. I want to solve it, and I want to express the solution using interval notation. If I was you, I would just write down the inequality right now, pause the video, and try to answer it on my own, and then just compare answers. Okay, so let's kind of analyze the solution for this inequality. This inequality is definitely linear. I'm looking at all of my variables, so x, and what I notice is that there's no exponents, there's nothing crazy with them, so they are linear. This is a linear inequality. So it is a polynomial inequality. It's a polynomial of degree 1. And the first thing that I'm going to do in order to solve this inequality, I mean, this is maybe a little bit of overkill here, but I am going to distribute, collect like terms, and set the inequality equal to 0. So then that means let me distribute this 3. So that becomes 3x plus 12 plus 2 bigger than or equal to 5 plus 4x. I am adding 12 and 2, that's 14. And then I'm going to set things equal to 0. It doesn't matter where the 0 ends up. I ended up leaving the 0 on the left hand side. That means I need to subtract a 3x and subtract a 14. And if I do that, I end up with 0 is bigger than or equal to negative 9 plus x. This right here is a polynomial inequality. It's a polynomial of degree 1. And now I could use the steps that were that we came up with earlier. You know, I could solve the polynomial equation, plot the solutions. In this case, it's overkill. I mean, here at this point, we can just literally solve now the inequality. So at this point, it's easy to solve. I could just add a 9 to both sides, and then this inequality would just say 9 is bigger than or equal to x. And the interval notation for that is, well, negative infinity to 9, including 9. This is easy to solve right now because we're dealing with a linear inequality. In a second, we'll deal with other types of inequalities and things will be a little bit more difficult. Alright, but let's just entertain the idea. Let's just pretend that we're actually going to use the steps that we came up with to solve polynomial inequalities. So this is my polynomial inequality right here. Step 1 would be to solve the corresponding polynomial equation. So 0 equals negative 9 plus x. So I solve that. My solution is x equals 9. Step 2 says to plot the solutions on a number line. Okay, so I have my number line, I have plot 9. And right now, I know that because right now I have bigger than or equal. This type of inequality says that I am including the value 9 in my solutions. So there's going to be brackets involved, and this is a solid dot right here. Okay, so I put the solution of my polynomial equation on a number line, and what that does is it splits my number line into some intervals. In this case, 2 intervals. Negative infinity to 9, and 9 to positive infinity. And now what I gotta do is I gotta grab values from each one of these intervals and test them, plug them into the original inequality, or plug them into this other equivalent inequality that we came up with. So here I have some test values. X equals 8 is in the interval negative infinity to 9. X equals 10 is in the interval 9 to infinity. So I am grabbing test values from each interval. And what I do is I test them either into the original original inequality. So the thing that we started with originally, or we can also test into this equivalent simplified inequality. And if you test, you'll discover that it's x equals 8 actually satisfies our inequalities. X equals 10 would not satisfy our inequality. So our solution set is negative infinity to 9, including 9. There's a bracket on our answer. Okay, so hopefully this one wasn't too bad and we agree on the solution. Alright, so let's solve another polynomial inequality. This one is quadratic. So it might not be as trivial as the previous one. But let's try it. At this point, you should pause the video, try solving it, and then we'll go ahead and go through the process here. Okay, so the first thing I'm going to do is what's going on here? So the first thing I'm going to do is set it equal to 0. I'm going to set this equal to 0. I'm just having some issues here with OneNote. Let's see, give me 1 second. Let's see if sorry, my computer's freaking out. Okay, let's solve this one. So let's, we said that the first thing we wanted to do is set equal to 0. And I put this in quotations because it's not really an equation. So what that means is just do this. It's subtract a 4 from both sides. So 3x squared plus x minus 4 less than or equal to 0. And remember that if you end up multiplying or dividing by a negative, the inequality sign would flip, would change. But we haven't done that. All we did is subtract 4. Okay. Now I'm going to start thinking about my steps for solving polynomial inequalities. I'm going to say, step 1, I am going to solve the corresponding polynomial equation. 3x squared plus x minus 4 equals 0. I need to solve that. How do I solve that? Factoring would definitely help. Factoring is it's crucial, it's fundamental, it's elemental. Practice it a lot. So let's see. Let me try to solve this. So I'm going to say 3x. Right now I'm just kind of using trial and error method. X, and this is equal to 0. And now I gotta think, I think what's going to end up happening here is something times something is supposed to multiply to 4. So I think it's going to become 4 and 1. And what I'm going to say is this. I'm going to say, well, it's supposed to multiply to negative 4. Positive 4 and minus 1. I think that's going to work. Because now 3x times x, that's 3x squared. 3x times negative 1, that would be negative 3x. 4 times x, that would be positive 4x. And that gives me x in the middle. And that's good. And then 4 times negative 1, well, that's negative 4. Okay, so then that says that I have two answers. I have the answer x equals negative 4/3 and x equals 1. Okay. So let me give myself a little bit of room here. Now what I'm going to do is our step 2. I am going to go ahead and put these values on the number line. Alright, well, I don't know, negative 4/3. And right now I'm dealing with less than or equal. Less than or equal. So my boundary points will be included. So I'm going to draw them as little solid dots. I'm going to say that that's negative 4/3. And over here I will put 1. Okay, and what this has done is it has split up my number line into 3 intervals. Negative infinity to negative 4/3. Negative 4/3 to 1. 1 to positive infinity. And note that here I'm using brackets in all of these intervals. The reason why that is because of the type of inequality that we're dealing with. It doesn't mean that if I put all of these 3 intervals together, I get the real number line. There would be some overlap here. So right now I'm just kind of thinking about my 3 intervals created by these 2 values here. Okay, So then step three of our procedure to solve polynomial inequalities involves testing. So from each interval, I am going to grab values and plug them into my original polynomial equation, or I could also plug them into a simplified form. But sorry, my computer right now is being a little silly here, and it's not allowing me to do what I need to do. So just bear with me. Okay, so step 3, we said let's test values. And by the way, we had this polynomial inequality up here. I can write it in kind of factor form. I'm gonna do that because it's going to help me when it comes to testing. So I'm just gonna factor it x minus 1 less than or equal to 0. Okay, so let's test values. Well, we gotta pick some values. Let me pick some values. So let me first think of a value that's between negative infinity and negative 4/3. So let me grab an x value that's between negative infinity and negative 4/3. I don't know, can you think of some x value, something convenient there? What about just negative 2? X equals negative 2, yeah? Let me think of something that lies on this other interval, negative 4/3, 1. I would say maybe x equals 0. That's convenient. Let me think of something that's on this other interval, 1 to infinity. I don't know, x equals 2. All right, so I think those are some not too difficult to deal with test points, and so let's use them. Let me just give myself some room here. Okay, so let's test. I am going to plug in negative 2 into my inequality up here and see if it satisfies it. So let me see. I'm going to have negative 6, because that's what I would get if I do 3 times negative 2. Negative 6 plus 4 times negative 2 minus 1. Now, is that going to be less than or equal to 0 or bigger than or equal to 0? What do you think? So here what's going on is you're multiplying a negative times another negative. This is bigger than 0 because it's going to become positive. So it seems to me that this interval is no good. Okay, let me think about 0 here. If I plug in 0 into this inequality up here, I'm going to have, well, that's just going to become 4 right there, and this is going to become negative 1. So 4 times negative 1. And that's definitely less than 0. So this looks like a good interval so far to me. Now let me test the last point into my inequality, x equals 2. If I plug in 2 into my original inequality, well, this is not the original inequality, but it's just the factor form. It doesn't matter, you could actually plug it into the original inequality. It's just that the arithmetic would be a little bit more cumbersome because you would have to be squaring things and a little bit more arithmetic. I like plugging it into the more simplified form of the inequality. So let me plug in 2 into it. So if I plug in 2 into this inequality, I'm going to end up with 6 plus 4. 6 plus 4 times 2 minus 1. And that's going to be a positive times a positive. So that's going to be positive. And remember, we want to end up being less than or equal to 0. So that's no good for us. So this does not satisfy my inequality. Yeah? And so then I think we have found our solution set. Our solution set is negative 4/3 1 inclusive. So I think we're done. So we're going to say that the solution set is negative 4/3, 1. Okay, I hope you agree with that answer. And good. Let's move on to the next one. All right, so this is another quadratic inequality. There's another quadratic inequality. You should pause the video and try solving it on your own. You should pause this video at this point, try solving it on your own, and then let's compare answers. Okay, let's see. This is convenient already because it's already set equal to 0. This is already set equal to 0. So pretty much all I have to start doing here is going through my steps of solving polynomial inequalities. So I'm going to say step 1, I'm going to solve the corresponding polynomial equation. X squared minus 7x plus 10 equals 0. That's what I'm going to begin by doing. Okay, factoring. Can you think of some factors of 10 that add up to negative 7? Well, I think we're dealing with x minus 5 and x minus 2. I think that's how this factors. Yeah, so that gives me two answers. X equals 5 and x equals 2. Okay, so I'm going to rewrite my inequality in factor form. I'm going to rewrite my inequality in factor form. So this just becomes x minus 5 times x minus 2 bigger than 0. Okay, step 2 we said is to go ahead and plot these solutions that we found to the polynomial equation in a number line. So step 2, I'm going to put them in a number line. So I have 2. And right now, you see, I'm dealing with a strict inequality. So right here at 2, technically I have sort of like a little empty. I'm gonna draw it with an open dot because it's a strict inequality. So 2, same thing over here. I'll say at 5. Okay. And so then what I have is 3 intervals again. I have the interval negative infinity to 2. Now I'm using a parenthesis because 2 is not included. I have the interval 2 to 5, non-inclusive, and I have the interval 5 to infinity. Yeah? And so then my step 3 is to test values. Okay, so let me pick some values from each one of my intervals. So let me think about this interval, negative infinity to to 2. Negative infinity to 2. I'm going to pick the value x equals 0. That's convenient. From the interval 2 to 5, I'm going to pick the value x equals 3. And from the interval 5 to infinity, I'm going to pick the value x equals 6. Yeah? Now let me test. So if I plug in 0 into my inequality up here, I'm going to end up with this product. I'm going to end up with the product negative 5 times negative 2, which is positive because it's a negative times a negative. So this looks like a good interval right here. Now let me test my value x equals 3. If I plug in x equals 3 into my inequality up here, I'm going to have the following product. I'm going to have negative 2 times 1, which is negative. And that's no good. That's no good. That tells me that this interval is not part of our solution set. And then lastly, let me test x equals 6. Let me test x equals 6. I'm going to plug it into my inequality up here. So if x equals 6, I'm going to have 6 minus 5, so that's 1, and 6 minus 2, that's 4. 1 times 4. And that is bigger than 0, so that is a solution. Yeah. So right now, my solution set is this interval together with this other interval. How do you put two intervals together? Well, with interval notation, there's well, interval notation, what it is just sets. And sets, you can do operations with sets. There are two operations, one of them called union and one of them called whoa, what happened here? Union and intersection. Sorry about my computer. I apologize. It's being a little glitchy. I think at this point we're done. We have found our solutions. Our solutions are the following. So we're going to say solution set. The solution set right now is negative infinity to 2, union 5 to infinity. Okay, so I hope that you got this inequality correct and you were able to follow the steps correctly. Good. Let's do a couple more inequalities. Let's deal with a cubic one. So this one is a cubic inequality. It's the similar situation. It's a similar situation. It's just that now you're going to have to solve a cubic equation. So pause the video, give yourself a few minutes, and then let's just compare answers. Okay. I guess I'm going to begin by, again, this is convenient right now because it's already set equal to 0. On one side of my inequality there's a 0. When there isn't, you definitely want to kind of set things equal to 0 first though. So right now it's convenient, it's already set equal to 0, so I'm going to jump right into the steps of solving a polynomial inequality. So I'm going to begin with my step 1. I'm going to solve the corresponding polynomial equation. Okay, so let's see how do I solve that? What can I possibly do to solve this? Do we have a cubic formula? There is a cubic formula out there, but we don't talk about it much. I think factoring is going to be the tool that's going to be our friend here, is if we're dealing with a polynomial of degree 2 or higher, or of degree 3 or higher. So let's see, what I notice here is that my polynomial only has 2 terms, it's of degree 3, only has 2 terms, and I will factor out whatever common term they have. It turns out that they have an x in common. So let me begin by factoring out an x. Okay, so if I factor out an x, I end up with 4 minus x squared. Okay. Now, I think, now I'm looking at the thing inside this parentheses, the 4 minus x squared part. Is there a way that I can factor that further? I mean, if you're thinking x squared minus 4, well, it's the same thing. It's the same thing. Turns out that it does factor. This is, the thing inside my parentheses is just a difference of squares. It's a perfect square minus a perfect square. So it should factor. It factors like this. And don't forget that we have this x out here. This x, we cannot lose it. So then I have x times, the thing inside the parentheses is going to factor as 2 plus x times 2 minus x. And if you want to just multiply this out, you'll see that you end up with this. So 2 times 2, that's 4. 2 times negative x, that would be negative 2x. X times 2, that would be positive 2x. Those terms cancel because it's negative 2x plus 2x. And then x times negative x would be negative x squared. and x is multiplying that product. And so there's just a lot of multiplication here. So I'm just going to write it like this. X times 2 plus x times my computer's just being kind of dumb, I'm sorry. Takes forever to switch from eraser to the pen. I think it's because I am using a lot of the CPU for this video, but such is life. Just bear with me here. I just want to erase this. You get the idea. There's going to be three solutions. X equals 0, x equals -2, and x equals +2. Okay, so from this part I have that x equals 0. From here I have that x is equal to -2. And from here I have that x is equal to +2. And you should verify that. I mean, you should say 2 minus x. So 2 minus x equals 0. Well, then you have to subtract a 2. And then you have -x equals -2. And then you multiply both sides by -1. And that would just say that x equals 2. Okay. And so now what I gotta do is I got to kind of continue. Well, now I have, I'm at step 2. I gotta plot these points on a number line. And right now I'm dealing with a less than or equal inequality, or bigger than or equal inequality. So I'm gonna use solid dots. So I have -2, I have 0, and I have +2. And what that does is it splits up my real number line into 4 intervals. -infinity to -2. Right now I'm using brackets because, again, of the type of inequality that we're dealing with. -2, 0, 0, 2, and 2 to +infinity. And now what I gotta start doing is testing values. Pick some test values from each interval. I gotta, from each interval, pick some test values and see what satisfies my inequality. So let's think about that. So let me pick here. I'm getting into step 3. Picking some values from each interval. Let's say here I'm gonna have x equals -3. From here I'm going to say x equals -1, x equals 1, x equals 3. And then I gotta test them into my inequality. And right now you can think of the inequality as being this. Originally it was this cubic inequality right here, but I'm gonna rewrite it. I'm gonna rewrite it over here in factor form. In factor form it looks like this: x times 2 plus x times 2 minus x bigger than or equal to 0. It's the same thing. I just like this version a little bit better because it's easier to test things into. Alright, so let's see. If my x is equal to -3, if my x is equal to -3, I'm going to have the following product. -3, because that's x, and then 2 times -3, that would be -1, and then 2 minus -3, that would be 5. And is this bigger than 0 or less than 0? I would say that this is bigger than 0. And I hope you agree. It's 2 negatives. Well, that's going to become positive times a positive is positive. So this is a good interval. Now let me think about this value right here. X equals -1. That would say -1 times 1 times -3. Sorry, it's not -3. It's +3. because my x is -1, so that would just be -1. This would become +1, and over here I would have 2 minus -1. 2 minus -1 just becomes 2 plus 1, so 3. And this is less than 0, so that tells me that this is not part of my solution set. I cannot use black ink, that's okay. Let me use x equals 1. So let me use x equals 1. If my x is equal to 1, I'm going to have 1 times 3 times 1. 1 times 3 times 1. And that is definitely bigger than 0. So this is okay. And then the last test value, if my x is equal to 3, I have the following product. 3 times 5 times -1. And that is less than 0. So this interval is no good for me. So I think I have found my solution set. My solution set is -infinity to -2 with a bracket, union 0 to 2 inclusive. All right, last example, last exercise in this section. Sometimes you end up with inequalities that look like this. There are two inequality signs. This is called a compound inequality. And turns out that this is also linear. There are a couple of ways of tackling this. One way would be to just treat it as two inequalities. So one method would be to treat it as two inequalities. One of them is this, -5 less than or equal to x minus 3 over 3, and then we could also say x minus 3 over 3 is less than or equal to 1, and then solve each one of them. And then just solve each one of them. Or there's, I mean, this is a totally good method. There's method 2. In method 2, what I'm going to do is I'm going to solve both inequalities kind of at the same time. So up here I would say then solve. In method 2, I would do, well, in method 2 I'm not really going to rewrite anything. I'm just going to start with the compound inequality. And I am going to do, right now I have the left part, the middle part, and the right part. And whatever I do to one part, I gotta do to the other two parts as well. So I want to isolate x if possible. So to isolate x, what I'm gonna begin by doing is multiplying both sides by 3. And keep in mind that if you multiply or divide by a negative, the inequality signs would change. Both of them would change. But right now I'm multiplying by +3, so nothing happens. So -15 less than or equal to x minus 3 less than or equal to 3, because I multiplied both sides by 3. And now I am going to add both sides. I'm going to add 3 to both sides. Okay? So +3 +3 +3. Alright, so then that's -12 less than or equal to x less than or equal to 9. And so then supposedly this is my answer here. This is my solution here. This is my solution, -12 to +9. Yeah? But I think, let's see. -12 to 9. No, that is our solution. That is our solution. So that is it for that one. You can check your answer here. I mean, if I pick something that's less than -12, like -13, it's not going to satisfy my original compound inequality. If I pick something that's bigger than 9, it's not going to satisfy my original compound inequality. So this is my solution set. You could have also obtained this from method 1. The only thing is that you would have had to solve 2 different inequalities and then think about the intersection, the overlap of the solution of each one of those inequalities. Okay, so this is the first part of dealing with inequalities. Right now we've been dealing with just linear inequalities. In the next video, we'll deal with rational inequalities. Okay, so thank you, and I'll see you in the next video.